Our next task is to create the paddle interactions. When a user places a finger on the display, Surface recognizes it as a finger and treats the contact as such, allowing finger-like interactions like drags, flicks, and spins. If Surface does not recognize the object on the display, Surface regards it as an unknown object called a blob and sends information about its size and shape to the application. At that point, it's up to the developer to either handle this unrecognized object or ignore it. The air hockey paddles have a very specific size and shape. When Surface detects a blob of that exact size and shape, the air hockey application will treat it as a paddle. Otherwise, the application will ignore it, thereby preventing unwanted interaction with other objects like palms or forearms. To create the paddle, we will create a class called a contact handler. The physics panel library already contains a number of standard contact handler classes to perform common tasks like converting a finger into a picking object to enable drag and drop in the physics world. What we need is a new contact handler, one that will turn a blob into a paddle, so we will call it blob_is_paddle. Creating a custom contact handler is fairly easy with physics panel. Any new contact handler needs to do two things: extend the addsPhysicalObjectBase class and implement the iContactHandler interface. Let's take a look at addsPhysicalObjectBase first. The addsPhysicalObjectBase class defines a few simple properties: height, width, mass, z above world, and initial velocity. Height, width, and mass are properties that define the size of the physics object to add to the physics world. Note that there is no depth property. When the user puts a finger or other external object on the Surface screen, Physics Panel has no way of knowing the intended z position of the interaction. Therefore, physics objects added to the physics world take up the entire z-axis, like inserting a very tall cylinder from the top of the physics panel all the way to the bottom. The z above world property defines the point on the z-axis that this insertion begins, and the initial velocity is the speed of the insertion. We will use these default values in our blob_is_paddle contact handler. Now let's look at the iContactHandler interface. iContactHandler defines 6 methods: onDownHit, onDownMiss, onMove, onUp, calledOnPreview, and getZResetBehavior. onDownHit and onDownMiss define the behavior for when contact is made or missed on a physics object. OnMove defines what happens when the contact attached to the physics object is moved. OnUp defines what happens when the contact attached to the physics object is picked up off the Surface screen. CalledOnPreview defines whether the actions take place on tunneling, or the preview phase of the event cycle, or the bubbling phase. And getZResetBehavior defines what happens if the physics panel needs to reset the z position of the contact physics object. Now let's take a look at the implementation of this interface in blob_is_paddle. First, we implement onDownHit and onDownMiss. Regardless of what object the paddle is placed upon, whether it's the floor, puck, or a wall, blob_is_paddle will create the physics object the same way. Therefore, we will have both methods return the value from a common method called commonDown. The commonDown method first checks to make sure that the oEventArgs is a ContactEventArgs object. If it is, then it creates a new CMObjectAdded object, sets its add position to pause, the point of contact, and sets needsHitTestOnMove to true to make sure that when this contact is moved, the physics object needs to be hit tested for collisions. The method then checks the ContactEventArgs to make sure that the contact is not a finger or a tag. Then it checks the contact's physical area property to ensure that it's the right size to be a paddle. If it is, then it passes the rest of the paddle creation on to a method called makePaddle, which we will look at next, and calls the ContactCapture method, passing it the physics object's framework element created in the makePaddle method. The makePaddle method first creates an ellipse as the framework element to connect to the physics object. Then it creates a new physics body. The method sets the physics body's picking type to mirror interaction, sets isDragging to true, sets the mass, velocity, and move impulse factor, which is a property for how swiftly the drag movement takes place. Then the method creates a WPF cylinder shape for the shape of the physics body. It determines the position the physics object will initially be created at using a method to convert the two-dimensional contact position into a three-dimensional position in the physics world using cmPositioner.pos2d to pos3d. Then the method calls PhysicsPanel.setPhysicsBody to join the physics body to the ellipse and adds it to the physics world. The last complex part of the IContactHandler implementation is OnMove. OnMove verifies that OEventArgs is a ContactEventArgs object and that the CM object added is not null. Then it checks the framework element in the CM object added, which should be the ellipse created in MakePaddle. If it exists, it calls the MoveTo method to execute the move of the physics object. If the framework element does not exist, then the method will create one with MakePaddle, much like the behavior of the CommonDown method. The implementation of the remainder of the IContactHandler interface is a piece of cake. The OnUp method simply verifies that the OEventArgs is a ContactEventArgs object, releases the contact's captured framework element, and removes the physics object and framework element from the physics panel. CalledOnPreview simply returns false to indicate that interactions should happen on the event's bubbling phase, not the tunneling phase. And getResetBehavior returns zResetBehavior.none to indicate that no special action needs to occur in the case of a zReset. We can now register our contact handlers in the surface window markup like this. All three of our contact handlers are registered here. Standard finger pick to pick the puck. Standard finger is finger to allow finger to puck collisions. And our custom blob is paddle to enable paddle interaction. Now, when we place a paddle on the table, our contact handler will read the blob, measure it, recognize it as a paddle, and create a physics object in our physics world. We're almost done. The only thing left to do is handle collisions between physics objects. Whenever a collision occurs, an event is dispatched. Using the collisionEventArgs isOneOfElements method, we can determine which elements collided and respond appropriately. Here, our collisionHandler method determines what two elements collided and takes action like playing a sound if the puck collides with a paddle or wall, or registering a score if the puck hits a score wall. We've also added some animations and sound to round the game out, but that's material for another discussion. Thanks for watching. We'll see you next time.